What if I told you a shattered glass on the floor could reassemble itself and leap back onto the table? Sounds like a magic trick, right? Impossible. After all, we experience time as a one-way street. We grow older, not younger. We remember the past, not the future. That relentless forward march is what we call the arrow of time, and it feels like the most basic rule of our existence. But here's a profound and deeply unsettling secret, straight from the heart of physics. The fundamental laws that run our reality don't actually care which way time goes. They suggest a future where you grow younger is just as possible as the one we're living in. At the most basic level, time has no preferred direction. So why does our universe look so different? Why, for us, does time only seem to flow forward? The answer won't just challenge your perception of reality. It'll take us all the way back to the very beginning of the universe itself. Our entire lives are built on this forward arrow. We're born, we live, and we age. Our minds create a story, a narrative that moves from a fixed past through this present moment and into an unknown future. Every memory you have is of something that's already happened. Every choice you make rests on the assumption that its consequences will unfold in the moments that follow, not the ones that came before. This is the bedrock of causality. Cause always comes before effect. The cue ball hits the 8-ball, then the 8-ball drops into the pocket. You don't see the ball leap out of the pocket to send the cue ball flying back where it started. While that reverse sequence might look plausible for a simple pendulum or a planet in orbit, for anything complex, it just feels absurd. It's like watching a movie in reverse. Our intuition screams that time is a river flowing in only one direction. But it turns out our intuition is hiding a much deeper and stranger truth. The physicist's secret is a wild concept called time reversal symmetry, or T-symmetry. It means that for almost all the fundamental equations of physics, from Newton's laws to quantum mechanics, the direction of time just doesn't matter. You can take the variable for time, t, and swap it with -t, and the equations still work perfectly. They describe a reality that is physically possible. A planet orbiting the sun in reverse still follows the same laws of gravity. A video of two particles colliding looks just as valid played forward as it does backward. This isn't some fringe idea, it's a cornerstone of modern physics. The laws governing gravity, electromagnetism, and the strong nuclear force are all time-symmetric. They don't have a built-in arrow of time. They don't distinguish between past and future. So this presents a massive contradiction. If the underlying rules are a two-way street, why is our universe so stubbornly a one-way road? If the laws allow for a glass to unshatter, why have we never, ever seen it happen? The answer isn't that it's impossible, it's that it is unimaginably, astronomically improbable. And the reason for that has a name: entropy. Entropy is, simply put, a measure of disorder or randomness. And the second law of thermodynamics, one of the most solid principles in all of science, states that the total entropy, the total disorder of a closed system, will always increase over time. This law is the true source of the arrow of time we all experience. Think about an egg. It's a highly ordered, low-entropy system. Its molecules are arranged in a very specific way to make a shell, a yolk, and a white. When you drop it, it splatters into a messy, high-entropy state. There are countless ways for an egg to be a gooey mess on the floor, but only one way for it to be a perfect, whole egg. Now, the laws of physics don't actually forbid the shattered pieces from spontaneously pulling energy from their surroundings, reassembling into a perfect shell, and hopping back into your hand. The problem is, the number of ways for those molecules to stay a disordered mess is astronomically higher than the one specific sequence of events that leads back to a whole egg. The universe always moves toward what's most probable, and the most probable state is always more disordered. A clean room gets messy, a drop of ink spreads out in water, an egg shatters. It's not a law of force, it's a law of overwhelming probability. This is why we remember the past, a low entropy state, and not the future, a higher entropy state. Our brains, our memories, our consciousness itself are all processes that create more disorder. But this just kicks the can down the road to an even deeper question. If the universe always moves toward disorder, why wasn't it always a complete mess? If high entropy is the most likely state, why didn't the universe just start that way? This is one of the biggest mysteries in cosmology. The leading idea is called the past hypothesis, and it argues that our arrow of time exists for one reason. The universe began in a truly bizarre state of incredibly low entropy. For the last 13.79 billion years or so, ever since the Big Bang, the universe has been unwinding. The Big Bang wasn't a chaotic explosion in some pre-existing space. It was the beginning of space and time itself, an intensely hot, dense, and incomprehensibly ordered state. Think of it as a perfectly wound-up cosmic clock. The Big Bang wound it up, and ever since, it's been ticking down. The universe has been expanding, cooling, and constantly increasing in entropy. Stars burn their ordered fuel and radiate it away as disordered heat. Galaxies drift apart. The grand structures of the cosmos are slowly dissolving into a state of maximum entropy, a future often called the heat death of the universe. Our arrow of time, the one that defines our entire existence, is a direct consequence of that initial, pristine, low entropy state. We are living in one long, slow, cosmic exhale. So let's ask the truly mind-bending question. If our arrow of time is just a product of the Big Bang's neat and tidy beginning, what would a universe with a reversed arrow of time even look like? From our point of view, it would be a world of baffling miracles. Shattered glasses would reassemble. Smoke would pour out of the sky and funnel itself back into a chimney. People would seem to rise from their graves, grow younger each year, shrink into infants, and finally vanish. But here's the kicker. For someone living in that universe, it would all feel completely normal. Their arrow of time, dictated by entropy increasing in their direction, would point opposite to ours. They would experience cause and effect just like we do. To them, a glass reassembling itself on the floor would be shattering. A person unaging would just be their version of aging. The most profound difference would be in their minds. They wouldn't remember their past, our future. They would remember their future, our past. Imagine being born with the full knowledge of how your life will end, but having no memory of your childhood. Every hello would be a final goodbye, and every goodbye would be a first meeting. This leads to a fascinating, though speculative, cosmological idea put forward by physicists like Julian Barbour and explored by others like Sean Carroll. What if the Big Bang wasn't a singular beginning, but a central Janus point, named after the two-faced Roman god? From this one moment, two universes could have sprung into existence, each expanding away from the other in opposite directions of time. One is our universe, where entropy increases and time flows forward. The other is a mirror universe, an anti-universe, where from our perspective, time flows backward. To anyone living there, their time would feel perfectly normal, and they'd see our universe as the strange one running in reverse. This two-headed arrow of time is a theoretical possibility that pops out of the math. It suggests our arrow of time isn't fundamental, but local. We're on a river flowing away from a great cosmic waterfall. But on the other side of that waterfall is another river, flowing the opposite way. The people on its banks would feel the current pushing them forward, just as we do, never knowing their forward is our backward. Now, while most laws are time-symmetric, nature does have one tiny exception. The weak nuclear force has been shown to break this symmetry. But a grander, combined symmetry for charge, parity, and time, or CPT, appears to hold, suggesting that a mirror universe with opposite charge, mirrored orientation, and a reversed flow of time is a real physical possibility. Exploring ideas like this pushes the very boundaries of what we know about reality and forces us to question everything. If you enjoyed this journey into the nature of time, consider subscribing and hitting that notification bell. It helps us continue to explore these cosmic mysteries together. So, does time flow forward? For us, in our corner of the cosmos, it sure seems to. Our lives are governed by the relentless increase of entropy, a legacy of our universe's uniquely ordered beginning. But the fundamental laws of nature whisper a different story, of a deeper, more symmetric reality, where time has no favorite direction. It leaves us with a final, lingering thought. If you were born in that other river of time, in that mirror universe, would you even know? Or would it just feel like home?